Hello everyone. So today we're going over 4.1 exponential functions. Last time I talked a little bit about the exponential functions. I give the definition of the exponential functions. It's a function of the form f of x equal a to the power x, such that this a is positive, not equal 0. I mean not equal 1, and the x is any real number. Again, f of x, f of x equal a to the power x, such that x belong to the real numbers, and in the same times a is greater than 0 and a not equal 1. Why is not equal 1? Because if a is 1, so the function will be f of x equal 1 to the power x, and this is equal 1. So f of x equal 1 is a constant function, is not an exponential function. Okay, so this is the exponential function. I gave also some examples. The example is how we can graph the function of x equal x3 to the power x, and the function of x equal 1 over 3 to the power x. I mean, like the base is 3, and in the second example was 1 over 3. I mean, it's the radical for the 3. We see the relationship between these two functions. The relationship are both of them are inverse to each other. I mean, they are reflecting to each other on the y-axis. Also, we end the last class by giving this this graph. So the graph here, the graph of exponential functions. So I give you the general idea how you can graph any exponential function like this. I said, so here is the y-axis, here is the x-axis, and this is the x-axis again, and this is the y-axis. This is the graph of the function. This f of x equal 5 to the power x, such that I mean not 5 to the power x, is a to the power x, such that this a is greater than 1, and this function is f of x equal a to the power x, such that this a is between 0 and 1. Example for this, I gave example last time. I said f of x equal 1/2, for example, to the power x, or a is 1 over 3, or 1 over 4, whatever, any a between 0 and 1. But for this one also, I give example f of x equal 5 to the power x, for example, or f of x equal 7 to the power x. So the graph of this function, it's look like something like this. All the functions must pass this point. This point is 1, 0. I mean 0, 1, sorry. 0, 1. 0, 1. The x value, the x coordinate is 0, the y coordinate is 1. So the graph should be something like this. This function will not touch the x-axis, will be close to the x-axis, but will not touch it at all. So the graph of the function will look like this. But the graph of this function, it's supposed to be reflected around the y-axis, something like this. Okay. So this and this point is again 0, 1. Okay. This is the two graphs for this function, the exponential function. The f of x equal a to the power x such that a is greater than 1. Here f of x equal a to the power x, a between 0 and 1. This is the general graph for any function, for any exponential function. Okay. Now today we're going to give some example for this. So my first example is, my example number 1. So the example is find the function, the exponential function. Find. So the example is find the exponential function f of x equal a to the power x, whose graph is given. Whose graph is given. By the way, what is the domain for this function? What's the domain for this function? Domain.
Isn't that the x-axis?
Is all the x-axis. What is that called? All the value in the x.
Positive infinity.
Exactly, from negative infinity to positive infinity. What is the range?
Negative infinity to 1, close bracket.
It's from negative infinity. Look to the y-axis. Which value of the y we use it to graph this function?
1.
No, starting from this point is 0, but is not including, right? Goes to infinity. Do you see? But
Yeah,
for the
okay,
domain is all, exactly, all the x value, I mean like from minus infinity to infinity, but for the range starting from the 0, but the 0 is not including. Look, the curve will be close to the 0, but is not including, and all the value in the y-axis. Exactly, is greater than 0. So here is the range. The range is starting from 0, but does not include, open parentheses, to infinity. By the way, okay, what is the asymptote for this function? What is the horizontal asymptote? Anyone know what is the horizontal? Horizontal dot a. This is mean the horizontal asymptote is y equal what? Y equal, what is the line such that the curve will be close to this line, but they will not touch it at all? What is the line, the horizontal line, such that the function will be close to it, but they will not touch the line? What is the equation of the line? Y equal 0. Yes, y equals 0. The same things here. The horizontal asymptote is the same things, y equal 0. Why? Because we're looking for the line such that this line, look, this is my line. This is my horizontal line. This is the line. The curve will be close to this line, but they will not touch it at all. This is my line. Okay? And the same things for this side. Here is my line. So this line is called the horizontal asymptote. It's called the horizontal asymptote. Same things for here. This line called the horizontal asymptote. The equation of this line is y equal 0. Y equal 0. Now, what is the domain and the range for this function again? This is an important question. The domain and the range.
Domain is the negative
Again, what is the domain?
Isn't it negative infinity to infinity?
Yes, from negative infinity to infinity. All the x values, we use it to graph the red curve. So it's from negative infinity, this is correct, to the positive infinity. All the x values, we use it to graph the red curve. Now, what is the range? What's the range? What y-axis? What y in the what I value we use it in the y-axis to graph the red curve? Exactly, from the 0 does not include to the positive infinity. Now go back to my example. Find the exponential function f of x equal a to the power x, whose graph is given. So the graph look like this for the first one, and for the second one is look like this. Okay, so here is the graph. And for the second one, okay, this point again is always 0, 1. And this point here is again 0, 1. Okay, this curve for the first example here, this curve passing this point is 2, 25. And this curve passing this point is 3, 1/8. Okay, for the first one, who has any idea how I can find the function f of x equal a to the power x? What is the value for a? F of x equal a to the power x. My question is, what is the value for a? If I find the value for a, so I find the equation or the function formula for this curve. Anyone has any idea? How can I start thinking for this example? Will be 5, but how you think for this?
Can you use a slope, the slope?
The slope, but the slope, they will not help me for example for the exponential function. But what about Kizar, if I use this point?
Mhm.
How can I use this point, do you think? Do you have
Actually, I don't really have an idea right now.
What is f of 2?
F of 2 would be 25.
Yes, exactly. F of 2 equal 25. So plug the 2 inside this function. What I will get? F of 2 equal a to the power what? 2.
Okay.
And this is equal what? F of 2, they give me here
Oh yeah,
is
so
25.
it would be 5. Yeah.
Exactly. So the 25 actually is 5 to the power what? 2. So if I have the same exponent, so the base should be the same. So a actually equal 5. So a equal 5. Okay, who will do the second one? Same idea. I have a point. F of 3, what is that equal? 1/8. Someone he said 1/2. Let me check. So my function is f of x equal a to the power x. So my goal is looking for the value for a. What is the value of a? So to find the value of a, I have to plug the 3, and then I have to make it equal to 1/8. So f of 3 equal a to the power 3. And this is actually equal 1/8. And 1/8 actually equal what? Something to the power 3. What is that something? 1/2, correct. 1 over 2 to the power 3, same exponent 3. Now the base a equal 1/2. So a equal 1 over 2. Any question for this example? Okay. Now we have to know how to graph also the exponential function by using the transformations. Okay, let's go to the transformations. I mean, for transformation, how we can do shifting up or down, left or right, reflecting around the x-axis or around the y-axis without using the table, So we're going to learn how we can use our idea before for transformation for this function, for the exponential function. So my example now, use the graph f of x. So I'm giving you the example. I give you the original function here. You don't have to think what is your original function. Your original function is f of x equal 2 to the power x. To sketch the graph of each of the functions. First one is a g of x equal 1 plus 2 to the power x. Second one is h of x equal minus 2 to the power x. And the last one, C, is d of x equal 2 to the minus x. Okay, here we have 1 plus 2 to the power x. Here h of x equal to minus 2 to the power x. And here we have d of x equal 2 to the power minus x. Okay, for the first one, A. What is my original function? This is my original function of x equal 2 to the power x. This is like O of x, as we said before, if you remember. Before we was saying about this, O of x, but today they give you a name for this function is f of x. So how we can, so I have to write f of x equal 2 to the power x, and I have to modify this function to make it similar to the g of x. Then I can graph the g of x by using the function f of x. So how I can modify or how can I do something, what I have to do here to make it this function similar to this, to g of x. What I have to do, like adding, subtracting, plugging some values.
Add a 1.
Yes, exactly. Let's adding 1. So if I add 1 here, I get f of x equal 1 plus 2 to the power x. And if you look at here, this function is the same g of x. 1 plus 2 to the power x is the same as g of x. So this equal here g of x. Now to graph this function g of x here, I can rewrite this one as g of x equal 1 plus, here we add 1. This is 1 plus here. So I add 1 for both sides. This is equal 1 plus g of x, f of x. 1 plus f of x. So the function g of x equal 1 plus f of x. So what does that mean? Anyone can remind me what does that mean from the previous sections?
Does it mean like up one?
Yes, exactly. We have to shift the original function. This is my original one. We have to shift this function 1 unit up. So I know how to graph this function. The graph of this function like this. Like this. I said if a is positive, I mean if a is greater than 1, the graph look like this. If a is between 0 and 1, the graph will be like that. But my a in this example is 2. So it should be something like this. This graph, it's my function f of x equal 2 to the power x. So first of all, I have to graph the original function. Then I have to shift it 1 unit to the up. So after doing this, all these, I will get the graph of the function g of x. So here is my Cartesian plane. This is my Cartesian plane. This is my function f of x. Okay, be close to the x-axis, but they will not touch the x-axis. This point is 0, comma 1. This is my f of x equal 2 to the power x. Equal 2 to, because I have adding 1, it's the adding 1 is outside the function. I mean, outside the function is outside the parentheses of the function f of x. It's outside the parentheses of the function f of x. Because the 1 is outside the function, I have to shift all this black curve 1 unit up. So 1 unit up, it will be here. This is the point, 0, 1 will be 0 what? What is that point will be?
0, 2.
0, 2, correct. So this point is 0, comma 2. And all points, we have to change for the y coordinate. So this 0, 1, this 0, 2. This, for
I
example,
have a
1.
question.
Yeah, what's your question?
It's possible to think of the one like if, for example, it's not exactly the same form, but like example for like the mx plus b, how like the one will be the y, and the fx will be like the x type of thing.
You ask about the horizontal asymptote.
Yeah, I'm
You're
not
talking
sure.
about the,
I was
yes.
just trying to understand.
Look, all this point in this curve, the black one will be moving 1 unit up. 1 unit up means the 0, comma 1, the same coordinate of the x values, but the y coordinate will be changed. 0, comma 1 will be 0, comma 2. Now here is the horizontal asymptote for the black curve. Now my asymptote, my horizontal asymptote for the red curve will move 1 unit up. So here is 1 unit up. Same things. So this curve again will not touch the y equal 1. Will not touch it. Will be close to this curve, to this line. This is y equal 1. The red curve will not touch the y equal 1. They will be close to it, but they will not touch it.
Yeah, my question I guess is
Okay.
like, how would it look like if you were to move it to the horizontally, like instead of 0? Would it just say 0?
At 0, f of 0.
Yeah.
I mean, the x coordinate is the same when you're doing shift up for the black curve. But sometimes we're doing like shifting to the right, shifting to the left. It depends. But this point is always fixed, the black one. This point, always 0, comma 1. And in the exam, you have to show me this point, how is moving with the shifting, you know? I mean, like in the exam, this point is very important to show me if you like it will show me you understand what you like. It will show me if you understand what you're doing. Like for this curve, for this example, I mean, like when you do shifting to the up, the y coordinate will change from 1 to 2. The 0 will be the same. But sometimes we're doing shifting to the right. I mean, to the right, the x coordinate will change, but the same y coordinate. Like it will be like something like this. Like this. This point will be like 1, comma, y, because the x coordinate is 1, and the same y coordinate, y, comma 1, for example. It depends how you do shifting. I mean, yes, Amr, do you have a question? Can you explain again why and how the graph of f of x is that it is? Okay. So the graph of the function, the original function, to graph any, like this is a review, but look, the question is graph the function g of x equal 1 plus 2, 2 to the power x. First of all, to graph something like that, you have to write the original function like this, f of x equal 2 to the power x. Then you have to modify of this function. You have to add, subtract, plug some values instead of x to make it similar to the g of x. So in this one, some student, they said, just add 1 for both sides. So when I add 1 for both sides, I get 1 plus f of x equal 1 plus 2 to the power x, and this is equal g of x, this function. Y 1 plus 2 to the power x is the same as g of x. Now I can rewrite this here, this line, as g of x equal 1 plus 2, 1 plus f of x. Now, because we studied this section before and we learned all the rules for this section, to graph the function g of x, we have to graph the function f of x. Then we have to shift it 1 unit up because we have add 1. When we add 1 to the function from outside, we shift all the function 1 unit up. So my original function is f of x equal 2 to the power x, and the graph of this function is given from the previous slides, like this. This is the graph of f of x equal a to the power x, such that a is greater than 1. My a in this example is 2, so the graph should be like this. So this is my graph, f of x equal 2 to the power x. Now to graph the function g of x, we have to graph the function f of x, then we have to shift it 1 unit up. So shifting the black curve 1 unit up. This point is 0, 1. When we shift it up, will be 0, 2. And all the points will be shifting up. So the new curve will be like the same like the red curve here. Okay, any question? Is it clear, Omar? Okay. What's okay, for the part B, h of x equal minus 2 to the power x. For the x here the first of all, you have to know what is your original function. My original function is given, f of x equal, for the second one, the original function is given. What's the original function? It is here. Here, let me. Okay, so 2 to the power minus 2 to the power x. Okay, so to graph this function, I have to first of all write the original function, f of x equal 2 to the power x. What I should to do for this function to make it similar to the h of x?
You have to multiply the function by -1.
Exactly, multiply by -1 both of sides. So I will get negative f of x equal minus 2 to the power x. Now this is equal what? H of x. Now h of x is the same as minus f of x. H of x is equal minus f of x. So this told me, this is exactly telling me, is telling me to graph the function h of x. If you want to graph the function h of x, you have to graph the original function f of x, then you have to multiply by minus. What does that minus mean when I multiply the function by minus from outside? Yes, Omar. Anyone can remind me what is the minus outside when I multiply the function? Moving down, reflecting around which axis exactly? We reflected around which axis? The y or the x?
Is it the x-axis?
X-axis, exactly. We reflected around the x-axis. So this is my original function f of x equal 2 to the power x, the same like this, the black one. Here is the black one. Okay. Again, the curve will passing the point 0, 1. This point is 0, 1. Now we have to reflect it around the x-axis. Okay, let me bring this up. Okay, so here is the x-axis. We have to reflect all this point around the x-axis. So my mirror, now it's my x-axis. Here's my mirror. We have to reflect all the points. So the important points you have to show me when you graph something like this is the point this. When you reflect it, it will be here. And this point is
0,
what is
comma,
the
-1.
exactly 0, comma, this is correct, 0, comma, -1. This is the important point you have to show me when you graph something like this. Any question for this one? Okay, let's doing the last one is 2 to the power minus x. 2 to the minus x. Here's minus x. What we should to do? So my original function is f of x equal 2 to the power x. What we have to plug or subtract or when the number is negative, do you always reflect over the x-axis? Yes, when the negative is in front of the function, always we have to reflect it around the x-axis. Always, Sandra. When the minus is outside the original function, we have this is mean you have to reflect it around the x-axis. If this minus is inside the parentheses here, I mean like here f of x, f of minus x, something like this. This is mean we have to reflect it around the y-axis. Okay, so how I can modify this function to make it similar to this? I mean to this here. What if I plug -2 inside the function? F of -2, what I get? 2 to the minus x. And 2 to the minus x is the same as d of x. This is equal d of x. Exactly. So I have to plug the minus inside the parentheses. So I get minus f of minus x equal 2 to the minus x. And this is equal d of x. So now I have to rewrite this line as d of x equal f of minus x. This thing tell me to graph the function d of x. If you want to graph the function d of x, you have to graph the function f of x, the original function. Then you have to reflect it around which axis? Because the minus is inside, you have to reflect it around the which axis? Do you know? I just 1 second. I just told, yeah, exactly, Bilal. So I have to reflect it around the y-axis. So to graph the function d of x, I have to graph the function f of x, then I have to reflect it around the y-axis because the minus is inside the parentheses. So the same idea, same like before. Here is my x-axis, this is my y-axis. Here is the graph of the original function f of x. This function passing the point always 0, 1. Now my mirror, it's the y-axis. Here is my y-axis. Here's my y-axis. So I have to reflect all the points around this point. So my original point is 0, 1. What's the new position for the new point for 0, 1? 0, 1. Where is the new location for this point? Any idea? When you reflect this point 0, 1 around the y-axis,
Is it the same point or
the
not?
same point, exactly, thank you. Will be the same point, they will not move. So the same point. Now this will reflect like this, and this will reflect like this. So my point 0, 1. Very important thing, you have to write the function you graph it, like you have to label the function. This function, the red one is g of x. You have to label the function to know what function you graph it. So this red one is h of x, and the black one is f of x. This is very important to show me you graph the correct function. So this is f of x, the red one is d of x. Okay, any question? No questions? Okay. So now let's go to the new section 4.2. 4.2 talk about the natural. No, we skipped 4.2. We're going over 4.3, I think. Yes, the syllabus told me to go to the section 4.3. So here is 4.3, logarithm make functions. So in the first section, we talk about the exponential function. Today we're going over the logarithmic function. 4.3. Okay. First of all, anyone know what is the exponential function? How is the formula for the exponential function? Here is Jennifer. Do you know what is the formula for how the function look like, the logarithmic function? Do you know any idea about logarithmic function with base A? Okay, I'm going to give you, yeah, okay. I will give you the definition. So logarithmic, okay. Logarithmic function with base A, it's a function of the form. It is the function of the form f of x, logarithmic, the logarithm log like this. Logarithmic function with base A, this is the base, log x to the base A of the form, logarithmic x to the base A. Yes, exactly. Thanks. So I can say here y equal, because this is a function, y equal log x to the base a. Thanks, Aisha. So there is a relationship between the logarithmic function and the exponential function. So I can say here log, let me change the color, logarithm of x to the base a. This is equal y, right? And there is a relationship between the logarithm function and the exponential function. A to the power y equal x. A to this y equal x. A is called the base. This is the base. Okay, and this is my base here for the exponential. Okay, this is the exponent. This is called the exponent. And this is my exponent. So logarithm x to the base a equal y the exponent. This is the same as a to the power y. A is the base, y to the exponent equal inside the logarithm x. So this is the logarithmic form. This is called the logarithmic form. Form. And this is called the exponential form. Here, exponential form. Okay, some examples, evaluate. So my first example for this, evaluate. So first example for the logarithm, evaluate. First one, number one, logarithm 1000 to the base 10. What is that equal? Second one is logarithm 32 to the base 2. What is that equal? Who will do the first one?
I guess me. So,
Yes, go ahead.
okay, so the first one will be 10.
10,
like for like
okay.
the A, yeah, it will be
This
like
is
the A,
10.
yeah, 10, and then
10 to the power
the
10. 10 to the power 10. They will give me 1000.
yeah,
This is
1000.
correct. Is it correct? 10, is it correct? 10 to the power 10, they will give me 1000. Is 10 to the power 10 will give me 1000. This is correct.
Believe so, yeah.
10 to the power 10 is mean 10 times 10 times 10 times 10 times 10.
Oh
10
no, that would
times.
be 3, wouldn't it? No, 2. No,
Exactly.
it will be, yeah, 2, yeah.
2? Okay, 10 to the power 2. Is it equal 1000? 10 to the power 2 is 10 times 10. And this is equal what? 100.
No, that will be 3 times. It will be 3.
3, exactly. That is it. So 3. So the answer is 3 because 10 to the power 3 is 1000. So look, 10. The answer is 3 because 10 to the power 3 will give me 1000. 1, 2, 3. Why? Because look, this is equal 10 times 10 times 10. And this is actually 1000. Okay, any question? Okay, now for the second one. We'll do the second one. 2 to the which power is equal 32? 2 to the which power equal 32?
5.
5. This is correct. 2 to the power 5, they give me 32. 2 to the power 5 is equal 2 times 2 times 2 times 2 times 2. And this is equal what? 32. This is correct. So the answer is 5. Okay. Now we have some properties of the logarithm. We have some properties of the logarithm. It's fine, Layla. Okay. Again, before I move to the next slide, this is called the logarithmic form. I mean, for this one, this is called the logarithmic form. And this one here is called the exponential form. So there is a relationship between the logarithmic form and the exponential form. A to the power y equal x. And if you take a logarithm of x, logarithm x to the base a equal y. Logarithm x to the base a equal y. And here a to the power a to the y equal x. Okay. Now, we have some properties for logarithms. The first one, of log. Properties, okay. Properties of logarithm. First property, the first property said number one, the logarithm for any base, this is always equal 0. And actually this is correct. Why? Because a to the power 0, what is that equal? Equal 1, always.
1.
So this is correct. A to the power 0 equal 1. So logarithm 1 for any base always is 0. Here, by the way, this a must be positive. This a must be greater than 1 and not equal 0. I should write this thing. This a is greater than 1, greater than 0, and a not equal to 1. Okay. And this x must be positive. X is greater than 0. This is very important rules for the logarithm function. Number 2, the property said logarithm a to the base a is always equal 1. Always. Look, a to the power 1, this is equal, anything to the power 1 is the same as down a. And this is equal a here. So this is correct. Logarithm a to the base a is always equal 1. Number 3, logarithm a to the power x with base a equal x. Actually, this is correct. Why? Because if you look in here, log a to the power x a, this is equal here Actually, this is equal the x in front. We have to put the x in front. Log a to the power a, and log a to the power a by using the second property. This is equal 1. So actually, I get x times 1, and this is equal x. So the answer is x, correct. For the fourth one, logarithm, I mean like a to the base logarithm, x with base a, this is always equal a. Okay, any question for this properties? Do you have any question? Is it clear? Okay, so if it's clear, we're going to use example applying for this properties. So example number 1, we have some examples. Find the values for number 1. Is the logarithm for 5 to the power 6, I mean 7 or 6, whatever, for both the power 6, with base 5. What is that equal? Number 2, log 1 to the base 7. What is that equal? Number 3, log 6 to the power, I mean, I want to change the number 7 to the base 7. What is that equal? Okay, who will do the first one? Logarithm 5 to the power 6.
Would it be equal to 1 or to 6? I mean,
Exactly, it's equal to 6. It's similar to which property?
the third property.
Third one. Okay, nice. So the answer is 6. So my x here is 6, my a is 5. Number 2, who will do the second one? Number 2, logarithm 1 to the base 7. As I said, logarithm 1 is always what? Zero, always. The logarithm of 1 always 0. So logarithm 1 to the base 7 is always 0. Now logarithm 7 to the base 7. Which property? Number 2, look, is exactly 1. So the answer here is 1. Okay. Now graphing of this function, how we can graph the function, graph of the logarithm function. So for any function, any new function, we have to know how to graph the function by using the plotting point, I mean by using the table. Then we have to move to graph the function by using the transformation. So first of all, we're going to learn how to graph the function by using the plotting point. We're going to choose a point. Then we have to plug this point inside the logarithm. Then we have to find the values for the logarithm. But as we know, the calculator is not allowed for our exam and for this class. So we're going to use an easy values to plug it inside the function. So my example now, or before the example, graphs of logarithm functions. So I will show you how we can graph any logarithm function by using the plotting point, first of all. Then we're going over the transformation. So the example now, I'm going to explain this by using example. Graph the function, graph the logarithm function by using the plotting point. By the way, okay, graph algorithm function by using the plotting points. So if I have my function is f of x, or my function is the logarithm x with base 2, so the function is x log x with base 2. So to graph a function like this, we have to plug a point inside the function, then we have to get the points for this function. Because the function is logarithm, I'm supposed to choose a good points because I don't have calculator for this. So I will use the point 2 to the minus 2, for example, 2 to the minus 1, and the point 2 to the power 0. Why I use 2? Because I have the same base 2, and 2 to the power 1, and 2 to the power 2. So to graph a function like this, I have to plug the 2 inside the function. Plug the 2, plug this value inside the function. What I'm going to get here? The minus logarithm, here logarithm, of 2 to the minus 2 with base 2. What is the value? What's the value here? So as I said before, logarithm a to the base x with base a, logarithm a to the exponent x with base a is x. So the same things here, logarithm 2 to the power minus 2 with base 2 is minus 2, exactly. So here is the value minus 2. The same things for this value, logarithm 2 to the power minus 1 of 2, I get minus 1. And 0 will be 0, 1 will be 1, and 2 will be 2. Just plug this value inside the logarithm. Again, logarithm, this value 2 to the power x, 2 to the power 2, sorry, with base 2 is the same as this value is 2. Okay? And this value 2 to the power minus 2 is, what is the value here? What is 2 to the power minus 2? Anyone can tell me what is the value of 2 to the minus 2?
Is it 1/4?
1/4, correct. And 2 to the minus 1 is the same things. 1 over 2 to the power 1 is 2. 2 to the power 0 is always 1. Anything to the power 0 is always 1. 2 to the power 1 is 2, correct, Pamela? 2 to the power 2 is 4, correct. Now I'm going to graph this function. So I'm going to graph it in the same slide. So here is the x-axis, and this is my y-axis. Okay, starting at the point here, 1 and 0. 1 and 0. Okay, so the x value, the x coordinate is 1, and the y value is 0. So the order pair is 1, 0. Here is the order pair is 1, 0. So this point is 1, 0. For the second one is 2, 1. 2, here is 2, and 1 here, it's 1 here, around here. This is 2, this is 1. The point should be here. 2, 2. 2, 2 is 4. 4 and 2. So here is 1, 2, 3, and 4. This is 4, and here is 1, and this is 2. So the value should be here. Second one here is we have 2 to the minus 1 is 1/2 and a minus 1. So here is the minus, this is the 1/2, and here is the minus 1. The point should be here. 1/4 and minus 2. So here's the 1/4, and here is the minus 2. So the graph look like this. So this is the graph of my function for the logarithm function. So the graph will be close to the y-axis, but they will not touch the y-axis. So what is my asymptote? What's my vertical asymptote for this graph? This is 1, 2, minus 1. There's 1, 2. Is 1. What's the, is it 1? So my vertical asymptote is, it's this line. So the curve will be close to this line, but they will not touch this line at all. So what is the equation for this line? What's the equation of this line? C equals 0, x equals 0. This is the correct one. It's not C. X equal 1. Yes, x equals 0. So my vertical asymptote equal, so I'm going to put it in capital, equal x equal 0. This line, x equal 0. What's the domain and the range? What's the possible input what's the value for x I can plug inside the function?
Would it be 0, infinity?
Exactly, from the 0 to infinity, all this value, but the 0 is included or not? I can include,
I don't think it's included, no.
not include. This is correct. From 0 to infinity. All this possible input, I can use it to graph this function. Now, what is the range? This is the input. What's the range? Any idea? What is the y value we use it? Negative infinity to infinity. This is correct. Nice. Yes, this is correct. So all this, it's my range. So the range is from minus infinity to infinity. From minus infinity, comma, infinity. Okay. This is the graph for any logarithm function. Any logarithm function, it will be has a graph like this. Any logarithm function, the graph will be look like this. So this is the graph for any logarithm function. So let me remind you how is the relation between the graph of the exponential function and the logarithm function. So the graph of the exponential function, it's look like this. Here is the relationship between the two graphs. This is the graph of exponential function. Will not touch the x-axis, and passing this point is 0, 1. And this is the graph of the logarithm function. And this logarithm function will passing this point. This point is 1, 0. So this is log x to the power a, to the base a. And the black one is a to the y equal x. I mean, a to the y. Like this, a to the y. Or, I mean, a to the x, a to the x, a to the x. And here's the logarithm of x to the base a. Now, my question, as we see here, both of the questions are reflecting around the curve. If you're looking here carefully, you will see both of the questions, both of the curve, the exponential function, and also the exponential function and the logarithm function, both of them are reflecting around this line. This line is y equal x. And this is mean both of the function are inverse to each other. Both of the function are inverse to each other. So the logarithm function is the inverse for the exponential function, and the exponential function is the inverse of the logarithm function. That's why it's reflecting around this line. This line is y equal x. Any question? Is it clear?
Can you go back to the first page for a quick second?
Yes. This one?
Yes. I have a question
Okay.
of, so is domain 0 because it's close to 0, it's approaching 0?
Yes, it's approaching the 0, but they will not touch the 0. So I cannot plug 0 inside this function.
Also,
That's why starting. Like,
so we
look
put
to the curve.
0. So we put 0 because it's approaching it, but it can't touch it.
Yes.
And then that's why it's an open interval.
Yes, that's why. Correct.
And so how do we find the vertical? How do we know where's the vertical asymptote?
Because you ask yourself what line, here's we have a vertical asymptote, what vertical line, this curve will be close to this line, but they will not touch it. So as we see here, in the end of this curve, this, the blue curve here, will be close to this line, the vertical line, this one. This is x equals 0. Will be close to this line, but they will not touch this line.
Oh,
That's
so
why-
vertical asymptote is basically the line that it's close to but won't touch.
Yes, close to,
Okay.
and they will not touch. Exactly.
And so this one, is it gonna have both a vertical and a horizontal, or only vertical for this?
This is only vertical
Oh, so how do you know which one has only vertical?
because as you see here, if I want to graph like horizontal, I don't have asymptote. Like,
Oh,
look,
because because it's to infinity.
yes, that's
Okay.
why. But if I graph vertical, I will see looking for like I will see there's a vertical asymptote. I will see asymptote vertically, and the
Oh,
asymptote is here. I can see it by my eye. It's close to the 0, but they will not touch it. That's why this function has a vertical asymptote.
okay. Thank you.
No problem. So the relationship between the logarithm function and the exponential function is they are inverse to each other around the line y equal x. Now we're going to learn how to graph any exponential function by using the exponential. I mean by using the transformation. So here we have example. Now we're going over to graph any exponential function. I mean any logarithm function by using the transformation. So graph each of the following by using the graph of f of x equal logarithm x to the base 2. So first one here is g of x equal minus logarithm x to the base 2. Second one, it's b, sorry, logarithm, d of x logarithm x plus 2 to the base 2 here. Okay. So for the first one, logarithm, we have minus logarithm 2, logarithm x to the base 2. Okay. Okay. Who can doing this? First of all, we have to graph the original function like we said before. We have to write the original function. My original function is f of x equal log x to the base 2. Now, how can I modify this function to make it similar to the g of x? What I should to do to make it similar to the g of x? What I have to multiply both sides?
Multiply both sides by -1.
Yes, multiply both sides by -1, you will get negative f of x, negative here, f of x equal logarithm, negative logarithm, negative log x to the base 2, and these things will be the same as g of x. Look, g of x is the same as negative logarithm x to the base 2. So here I can get g of x. I'm going to remove this one until I finish the first example. So here I can rewrite this function like before. G of x, this is just a review, g of x equal minus f of x. So this is told me if I want to graph the function g of x, I have to graph the function f of x, then I have to reflect it around which axis I have to reflect it here, because I have the minus outside. Minus is outside the function f of x. Which axis I have to reflect it, this function?
The x-axis.
The x-axis, correct. So I have to graph the original function is f of x. The graph for the f of x is the logarithm of x to the base 2. So the graph should be something like this. Here's the graph of the function f of x equal log x to the base 2. Now I have to reflect it around the x-axis because I have minus outside the function. So this is my mirror. It's my x-axis. By the way, the function is passing the point 1, comma 0. This point is 1, comma 0. This point is 1, comma 0. Now I have to reflect this function around the x-axis. This is mean the point should be like this. So when I reflect this point, it will be the same point, and all this point will be here, and this point will be go up like this. So this is the function. The red one is the graph of the function g of x equal minus log x to the base 2. Any question for this one? Is this one clear how we can graph the logarithm by using the transformation? Okay, so now let's go to the second example. The same one, but second part of this example. Second part of this example. So part 2 is P. They told me graph the function d of x equal logarithm x plus 2 to the base 2. Okay, so to graph this function, again, you have to know how is the graph of the original one. So my original function is f of x equal logarithm x to the base 2. Now what I should to do, how can I like changing this function to make it similar to the function logarithm x to the base 2 plus 2? What I should to do for both sides? If I have 2 for both sides, what I will get here? I'll get f of x equal what? Of x plus 2 equal logarithm x to the base 2 plus 2. And this is my d of x. Look, d of x. It's actually equal d of x. So the same idea, I have to write it again, d of x equal the function f of x plus 2. So this is told me if I want to graph the function d of x, I have to graph the original function f of x is the logarithm. Then I have to add 2. This is mean, what is this? This is mean, what this mean, the plus 2? When I add 2 to the function, do you know what does this mean when I add 2 to the function?
Does that mean
We
you
go up
shifted?
to.
Oh yeah, sorry.
Yeah, go ahead.
No, yeah, I was gonna say
Yeah.
yeah, just shift it up to 2
2
units.
Correct. So actually, thanks. So actually, I have to graph the original function. The original function is the logarithm function. This is my logarithm function. Also, always the logarithm function passing the point 1 comma 0 always, but the exponential function always passing the point 0 comma 1. Don't forget this point. This function is f of x equal logarithm x to the base 2. Now I have to shift it 2 units up. 2 units up means this point is 0, it's 1 comma 0. So it will be like the same things, 1 comma 2. When I shift this point 2 units, so it will be like here 1 comma 1, and this point will be 1 comma 2. So my new point will be 1 comma 2, and all the points will be shift up 2 units. So the graph it's look like something like this. Again, the graph will be close to the x equals 0, but they will not touch x equal 0. So the red one is d of x equal logarithm 2x plus 2. Okay, any question for this one? Is it clear? Okay, if it's clear, let's go to the common logarithm. Common logarithm. Here, by the way, I want to graph this. This means we have to shift it 2 units up. All the points should move 2 units to the up. Okay, now the common logarithm. Anyone knows what is the mean of common logarithm? Have you heard about this?
Is it the natural log?
The natural
Like
log or the 10?
the
The other
what?
one, the natural log is different about the common logarithm.
Oh,
Yeah, the natural log with the, I will talk about this one, but the common logarithm is a logarithm. Anyone knows what is the mean of common logarithm before I define it? Anyone knows what is that? Is a logarithm to the base what? What is the base of this function?
10.
10, exactly correct. So this is called the common logarithm. So we can define it as defined by log 10 to the base. I mean log x to the base 10. We can write it this, always we can write it as log x without any base, log x. Log x means logarithm x to the base 10. We have small example for this. Example. So the example is log 10. What does that equal? Find the value. And also log 100. What's that equal? What is the logarithm of 10 equal?
One.
Is 1. Let me check. So logarithm 10, this is equal, she said equal 1. This is correct. Why? Because actually log 10, this is the same as log 10 to the base 10. And as we said before, log a to the base a, as from the property here, log a to the base a, the same a, is equal always 1. So the answer here is 1. This is correct. For the second one, what is log 100? Is 2 antecedents. Yeah, this is correct, because this thing here is the same as log 100 to the base 10. And you have to ask yourself, 10 to the which power they give me 100? Is 2. So 10 to the power 2, they give me 100. So the answer is 2. So this is equal to, and the first one equal 1. So this is 2, and this is 1. Okay, so now going to the natural logarithm. This is called the common logarithm. Now the natural logarithm. Here, natural. Yes, I will go back. Natural logarithm. So this is the last logarithm for this section. Natural logarithm. Here you go, Jennifer. Anyone can define me the natural logarithm? What is the natural logarithm? Do you know what is the meaning of natural logarithm?
Is the base e?
Exactly. Is a logarithm? Is a logarithm to the base e. So here's the base is e. This is the different about the common logarithm. E. Do you know what is the mean of e? What's the value for e? It's 10 is not 10, no. It's between 1 and 2. I mean, it's between 2 and 3. So I can define it. What is the 2 and 3? What is the value exactly? Do you know what's the value? So I'm going to give you a hint. It's between 2 and 3. What is exactly? 2.7. This is the value for E. 2.718. Correct. So E, it's called the natural number. The natural number here is a number equal 2.718. This is the natural number. So the logarithm to the base E is defined by the log of x to the base E, and this is equal ln. This is called ln of x. So ln of x is equal, it's a logarithm it's the natural logarithm. Ln of x is the natural logarithm. So you have to know also, you should to know the ln x is the same as ln x equal y. This is equivalent to e to the power y equal x. This is equivalent to the y, because the ln of x, this is equal log x to the base e. Ln of x equal this, log x to the base e. and this is equal y. Suppose this is equal y, so e to the power y, e to the y equal x. We have some properties for this logarithm. The last things, the properties. Of natural logarithm. We have some property for this function, the same like before. But this, it's the same exactly like before, is not hard. So the first property, first one, number one, len of one. What is the len of one? What's len of one? What's the answer? Len of one is the same as log of one to the base
0.
what? Exactly, to the base e. And like before I said, log 1 to the any base is always what? 0. So the answer is 0. For the second one, number 2. What's the value of len of e?
That would be 1.
Exactly, it's 1. The same like before. Len of e, it's the same as log e to the base e. And because a and a are equal, like the property of logarithm, this is equal what? 1. Number 3. What's the len of e to the power x? Len e to the x. We'll do this one, e to the x.
That would be x.
Exactly, it's x, because len of e to the power x is the same as like before log e to the power x with base e, because we have the same base e and we have this raised to the power x, so this is equal x. The last property, number 4. E to len x. What's the value? What's the value? Like before is x. This, it's x, this x. Okay, I'm going to give you the last example for this section. The example is the last example. Find the value for 1 len e to the power 8. Number 2 len, open parentheses, this is equal and this is equal. So the first one is len e to the power 8, and for the second one is 1 over e to the power 2. What's the value? Okay, what is the value for the first one? By using the property, it's 8, correct. Using the property number 3, len e to the power x is always x. Here's my x is 8, so len e to the power 8 is 8. For the second one, this is a little bit harder than before, but it's easy. This is equal len to the what? If I want to raise this one up, if I want to raise the e to the power 2, what is that equal? When I raise it up, when I move it up, I want to move this one up. E to the what? E to the which power? Negative 2, correct. And len e to the negative 2, what is that equal? By using the same property like before, like this. minus 2, correct. So the answer is minus 2. Okay. Okay, have a good day, everyone. I will see you next, I will see you this Tuesday.
Can you go back one slide for a second, please?
Yeah, sure.
Hi, Professor. Have a great day.